All right, today it's going to be a short and sweet one. We're going to finish up here talking about how chemical equilibrium can be used to describe the proton transfer reactions of acid-base chemistry. This video is going to be short and sweet. We're just going to describe very quickly the ionization of polyprotic acids, or those acids that can donate more than one proton or hydrogen ion. So some quick terms here. If we have a monoprotic acid, it is an acid like hydrochloric acid that can only donate one hydrogen ion. A diprotic acid is an acid that contains two hydrogen ions. A great example of a diprotic acid will be sulfuric acid, able to donate two protons. Polyprotic then is going to be something that can donate three or more hydrogen ions. However, regardless of the type of acid that you have, keep in mind that acids only donate one proton at a time in a stepwise fashion. Because each polyprotic acid ionizes in steps, each hydrogen ion that's donated has its own or separate ionization constant, or Ka value. So as you take a look at what you've got in your notes there, generally speaking, the ionization constant of the first proton is greater than the ionization constant of the second and of the third. In other words, that first hydrogen ion is very easily lost. However, the subsequent hydrogen ions are not so much. And so as you look at, for example, sulfuric acid, that first proton or that first hydrogen ion is very easily lost. However, that second hydrogen ion, although there will be some dissociation, many times it reverts to the hydrogen sulfate ion that you see on your screen there. And generally speaking, the difference is in these Ka values is great enough so that the second ionization does not happen to a large enough extent to affect the pH. In other words, for many polyprotic acids, you only have to focus on the ionization constant of that first hydrogen ion. The others aren't gonna happen to a large extent. Okay, now as you look at your notes, you're given a quick table there of some common polyprotic acids. As you look at the Ka values, for the most part, the second and third ionization constant values are going to be so small as to be insignificant. Sulfuric acid is the only exception that you need to recognize, in which the ionization constant of that second proton will play some role in affecting the pH. And to better illustrate this, I've provided a link in your notes to a really thrilling YouTube video that illustrates what's going on with sulfuric acid in solution. As always, a quick reference to all the images that were used in the presentation.